The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, my name is Nathan, otherwise known as Old Man Bills. We're in the Fright and Find Out Lab, man. We got John Bigman here with us. John, how you doing?
Welcome. I got an echo.
You got an echo? Hello?
Yeah.
Not here for the intro. No, I'm here for the intro. Sorry. You there, John?
Yep.
Okay, cool.
I still hear an echo.
Might be that phone. All right, hold on. We will just turn this off. How about now?
Yeah, you're like weaving time there.
You hear the echo now?
Well, I got to wait.
Okay. All right. Well, hopefully everything's good. We do some water experiments just to get started here. I'll try to use my cell phone to get some close-up shots. I got the Tesla coil over here. I have a Slayer exciter right here. I'm a power supply. Here's my Hitman coil right here. So what I figured we'd do is just start with something small. Just going to take this thing and pull the top off. And grab a little rod right here. There we go. Nice and tidy.
Just a plastic cover.
Yeah, just a little cover just to make it look cool and keep that rod straight. So here I have sand in here. And these are just little clips that look like this. I got a close-up of that. They're not attached together or anything like that. So
It's dry sand?
it's got a little bit of moisture in it, but not much.
By the way, it wasn't you, it was me.
Oh,
I had the echo.
Well, then that makes it a lot easier for what I'm about to do.
I'm sorry. It's my technical issue.
So here we go.
Yeah.
So we're going to take a look real quick. All right. Now I'm getting the echo.
Yeah, now I'm hearing it. Yeah.
Okay. Now it's better. All right. So here's the little clip right here. There's nothing really to it. It just goes down there so it can go in the sand. It does that on both sides.
Copper?
Yeah, it's copper. It's just a wall wire. I think it's 14 gauge.
Okay.
So nothing special about it. There's a light bulb connected right over here to the other side. It's a black light. So all I'm going to do is connect this right here. I have the whole thing off real quick. Get this thing fired up here.
That's just a regular DC supply?
Yeah, just a regular DC supply with the PMP circuit that I have inside here.
Mm-hmm.
They both just plug in right here. But anybody that doesn't know anything about this, they just plug into the sides.
Yeah.
If you ever need a hot wire, this is the fan.
Mm-hmm.
You can always pull the power out and put it in there, and the thing will start right up. It won't create much heat, so you'll be all right.
Yeah. That's just to cover your butt, right? the fan, basically.
Yeah,
Or
the fan's just to cool it down when you get up around 40 volts.
Yeah.
Need just a little bit of cooling, not much.
Yeah.
So let's take a look. So we got nothing going on with the light and everything. Make sure we're all connected. Oh yeah, we're connected. You can see a little bit of
Little spark.
a little sparkage.
Oh yeah.
So let's see if that we can get that light. Turned on.
Oh, I hear a high pitched squeal. Wow, that was good.
Yeah, it's gonna make some sounds that I can't hear. So good luck.
Yeah. Oh yeah. I can hear it. It's the squeal.
Look at how bright that is.
RF squeal.
Yeah, that's cool. Yeah, it lights right up as soon as you put the water in there.
And that's only one wire, right?
That's only one wire. We're only connected down the center. I'm not even connected to my Tesla coil. You saw me put the rod in. I just
Right. Well, inductively you're connected. You're coupled.
yeah, I'm coupled to it, but I'm not like connected. Like there's the number 2 right there. It's breaking out.
Yeah.
So yeah, it gets plenty of energy through there. So and
So wait, put the
14
phone
volts.
put the phone by the water again?
Okay, give me a second.
Near the water itself. The jar of water behind it. Yeah.
You pick on
It's
like a
definitely getting a
reflection?
high. It's a whine. It's a high pitched whine.
around the jar.
Yeah.
Oh, well,
I don't
there's
know
no
if it's
mic on this one.
I don't know if it's that or if it's behind it. Yeah, but it's changing something in the circuit.
Is that changing it? I'm touching it.
Yeah, it did.
Interesting.
Yeah.
Let's turn this one off real quick.
You're definitely modifying it. You are. When you move back and forth, it changed the tune of it.
Yeah, but body capacitance.
Yeah.
So let's take this different level here. Now we
So
got
it's
this.
acting like an antenna then.
Yeah, basically. You always have a little bit of body capacitance going on when you're around this stuff. I haven't figured a way to cut it yet, so it's still there. Hold on, let me set this down. Okay, so what I'm going to do here is I have this, and it's just connected up to the top of the Tesla coil. And I'm just simply going to put it into the sand and the water right there. And then we're just going to take one of these, just a 4-foot bulb with a light cover on it. I'm going to set it right over top of the water. Sorry, this thing froze. Give it a second. There we go.
Is that what happens? It freezes it?
Yeah, well, because it's wireless, and we're messing with everything.
Right. Ooh.
So there it is. We are at 13 volts. And we do have a breakout. You see that? I love that blue color. Coming out really nice.
It's funny how there's like 2 different sections to it.
Yeah, like it's blocking it in the center.
Yeah.
Watch this.
Oh.
You get a different sound?
Yeah. That it moves back and forth.
Yeah. Oh, there it goes again. Froze it. Give it a second to pop back up.
Might have to back away a little bit.
Yeah.
There it goes.
So I'm about 1.5 feet right now off the ground or off the water.
Yeah, it's conducting to you.
We,
See it around your hand.
yeah, absolutely. My body capacitance helps level it.
Yeah.
There's no question about that.
It's going through you to ground because you have water. You're 78% water.
Yep.
So
So
stuff loves water, dude.
Yeah, well, that's the thing I keep trying to tell people.
Yeah, it's very hydrogen positive.
So let's check this out. Let's just put it in the water. See,
Oh, whoa.
it's like a lightsaber now, huh?
You changed the frequency all the way down low.
Yeah.
It was up high before. It was like, wee, and then it goes, whoa.
Look at that.
Wow, that's deep.
So let's see how much we can change it now.
Interesting. Oh, way high. So you're like a huge capacitance to it.
Wow, big guy.
Yeah. You're like way high. So I wonder if your tune changes if you're healthy or not.
Oh, I don't know about that.
You know what I mean?
Yeah. Be interested, but we're not going down that road.
Remember all those guys like, Walter Russell and all those guys talk about it?
Mm-hmm.
I'm just wondering. That's all. Not going into it, but it's interesting.
But we'll try this. We got a black light, and we're connected here to a wire. We're just going to drop the wire in the water.
Right. Yeah.
There it is. Just lights up. And again, like you said, it likes me.
Everything you're doing is having an effect on the frequency.
It's kind of cool, huh? Makes it sound.
Yeah.
Here we go. Well, pause my phone again. Okay. So now I'm not even in the water. I'm just above it. It's lit up just a little bit. We're not at a very high voltage here. I mean, these water experiments, about 13 volts.
You don't need much with water. Yeah.
We'll go up just a little bit. We got about 15 volts in there now. Oh, now it's messing with my computer. Okay, hold on. I got to turn it down. It's changing my.
Oh. It just dropped. Oops. Well, your phone's still on, but your main camera's off. Reset your computer, huh? Oh, yeah. Oh. Ooh, unmute your mic. Well, we will pause. I think he may have been catastrophic. That's the problem. This is something I got to think about too. Shielding computers. Well, hopefully he'll be rejoining. Let me see. I know any good songs. Hold on a second. I got to connect. Oh, did he come back? Oh, he's back. Hello.
Yeah.
Nice to see you back.
It shut everything down.
Yeah, I saw. I was like, oh, this is catastrophic.
Oh wow! Good thing I figured it out. I was like, man, what's going on? Everything's off.
Yeah, you got to start thinking about shielding your computer.
Yeah, no kidding, huh?
Yeah,
We barely have this thing running too.
yeah.
This thing is so powerful. I keep trying to tell people, man, my computer's over 10 feet away.
Yeah, I would just
So
put like a wall and put some reflective paint on it or something, or carbon. It'll shield
yeah,
it enough. Carbon seems to work better. It conducts it away.
cool. All right, so we put this thing in water already. We got it to go. I don't know that I want to put that field that far over there again. Let's do something else. Yeah. What do you want to do? You want to go through and see what it happens to fruit and stuff?
Oh, here we go. Yeah, come on, burn it, burn it.
Let's see if we can't get a plasma reaction from a grape.
Yeah. You can do that in microwave.
No, I don't need a microwave. I just need my Tesla coil. Let's see. Okay. So this thing's up and going. So I'm going to add this back. There we go. All right.
That was at 13 volts, huh?
Yeah. This thing goes up to 40, man. You're going to shoot it right across the room.
Yeah.
Oh, hold on. There we go.
Oh, short out.
Yeah. Yeah, I hate that. These wires suck.
Oh, yeah. All right, the noise is back. Oh, yeah. Yeah, that's indeed hot.
Look at the blacklight light.
Yeah,
The blacklight's getting hot.
yeah. Well, it's a heavy current after that. It's interesting.
Yeah, let's turn it off real quick. Yeah, oh, I just heard something.
So is it positive? Are you using positive impulses?
So what's going on is the size of the rod is too big in this
Okay.
thing right now for the energy that's coming off of this thing. And what it's doing is it's flipping the field.
Right, but what's your Slayer exciter running? Negative or positive impulses?
I run negative. Everything's in a PNP, so it runs. It pulls the voltage through first.
Okay. So you're doing reverse bias then.
Yeah.
So it's negative, but you're getting positive out. And then you're flipping it.
Yep.
With the internal one. That allows you to transmit through the wire singly until you get to another capacitance where it'll flip it again and turn hot.
Okay.
Huh.
There we go. It breaks out again. Now they're not connected.
I bet you that's because of the discharge you got going on that wire
Mm-hmm.
on the secondary. Just sitting there, plasma all over. It's like a plasma speaker, basically.
Yeah, by the way, there is no ground on this. It's forced oscillation. So right here, this wire goes straight to my offset. That's going to go to my number 2 coil where ground would normally be. There's no ground on there. So, yeah, none whatsoever. It's just capacitance to ground. That's it. But yeah, they could be sitting apart, those grapes, and we're still lighting it up. So on those black lights, they don't come on that easy.
So I got some more information on the tower. I want you eventually go over with you whenever you want to, but because I know you were interested in talking about that.
Oh, yeah. Let's go over it after we're done.
Not now, but that's what I've been working on.
Nice. Yeah, a lot of interest in that tower. Let's see if it does the same thing through a couple
It's
of
not
circuits.
really the tower though. It's the actual coil system. The one you're kind of playing with.
Let's see. We don't have it lighting up yet. As soon as they touched, it came on.
Yeah. It's acting like a ground, like a virtual ground.
Ooh, I could smell it. Ooh.
Ozone?
No, it smells like burnt stuff. Ugh.
Oh, really? Oh.
Yeah, it's gross. Oh, man, I should really vent this garage. Wow.
Kilovolt chicken?
Yeah. Let's do this, man. Take that out of there. Stop playing with this. We'll just put it in orange, man. This thing takes a while to get in there. And we'll just take this thing and move it out. I'll just see if that orange is conductive at a distance. Well, why not, huh?
A wireless orange. I don't hear any squealing.
Nope. There we go.
There. Oh, yeah.
Yeah, it's conductive, all right. It's just,
Everything is after that point.
well, yeah, I mean, this thing is powerful. That's why I say when
Is
look
it
at
still energizing that big tub of water? Because it looked like that was coming from the tub of water.
well, it might be because the wire right here. Take a look. It's just sitting there. There's the
Oh, okay.
there's
It's
the
picking
orange.
it up.
It may be picking it up in there.
Yeah, that's acting like a loop of wire.
So let's bring it back on. I don't know.
Interesting.
Check it out. Well, I don't have any. Nope, it's not the tub. It
Well,
is
get
the
this
orange.
tube started. Get the tube started, and then
Well, it started now.
it's you. Okay, it's you. Okay.
This thing. Then these cell phones, man, they don't like these fields at all.
Yeah. Like I said, they got sensors in them. They can
Yeah.
detect E fields and stuff.
Well, that tube's still on.
So it is getting a little bit, but is it getting it from you? That's the question.
Well, I'm away from it now. So
Yeah,
I'm over by the Tesla coil.
It is getting a little bit.
Pretty interesting how this stuff works, man. These coils, they resonate really well, and it has to do with the STL that I built right here.
Yeah.
With all the different holes that I put into it, it distances them perfectly.
Yeah, having an ordered part of it is actually very geometry has a lot to do with it.
Yeah.
That's how I see it. Like bifilar coils, that's why they're special.
What I do like about this though is
Geometry.
it changes all the frequencies for you and self-corrects. Like we saw with the orange in there and everything, right?
Yeah.
Now pull the rod out and everything, and it'll correct itself again. And there it goes in a breakout. It has no problem going back to an oscillation mode with everything.
That's the static field, right? That's that part.
Static. I hate that word.
Well, you know what I mean. It's like that's the actual non-moving one until you get it to flow. So when you put a capacitance out there, it starts a flow from that coil to it.
Yeah, if you connected something to it, there's still no static. There's none. It's more potential.
Right. You're misunderstanding what I'm saying, but all right.
Yeah, probably. It's a potential field.
Yeah.
It's less like static, more like potential.
Static is pure potential. So
there's no static value to it, is what I'm saying.
Right.
There's
static just means it's not moving. It's not.
I'm thinking the word is like put the thing next to your arm, see if it lifts up the hairs on it and anything like that. It has none of that. So, all right. So yeah, all right. What else do you want to do? You want to see it go through anything else? I just about guarantee everything has a field in it.
Sure, everything has water in it.
We'll do this. This one's always fun. You think that'll light up at all? In any way?
Light up as in what?
As in pull energy through it.
By itself next to it?
No. I'm just going to hook the rod down the center again.
Okay.
And connect the wire to it.
I don't see why not. It's a single turn, right?
Yeah, it's just aluminum foil.
Basically.
Let's see. I don't want to put it too close to anything.
I like it when you ask me loaded questions.
Well, I've done this a bunch, so.
I know. I was going to say. It's unfair. You've done this on your own.
Just going to put this jar over here so the thing won't hit my coil again. All right.
I'll be going down this road.
Well, yeah.
This takes me a while.
I'll get there. Okay.
I got a TV to rip apart.
Oh, yeah. I love tube TVs. So there we go. We got it hooked to the primary of that coil.
Definitely can hear it. Yeah, it's acting as a single turn antenna. Nice.
Yeah. It pushes right through this field on that primary to the secondary part.
Now that it's changed, it's become like a chirping. It's very, if you bring it in close enough and just hold it there, it starts chirping. It's like kind of like.
Well, I think that's the mic on me when I lean over towards it, not the cell phone, because that one's muted.
No, it's the reaction of your capacitance to that setup. Because we can hear the
set that down.
Interference coming off it. Yeah, see? It's very high pitched now. And there seems to be like a pattern in there.
Okay, so you notice the frequency difference, right? So
Mm.
when I say it does like going down the hall and you turn on the light bulb just with their body capacitance, now you'll see what I mean. As I walk by it, the frequency changes, which means that I now can put something in resonance that it wasn't in resonance before.
Mhm.
Now, as I walk down a hallway and I have light bulbs and I'm a little bit out of resonance on my coil, as you can see here, now I could put it in resonance just by walking by it and it'll
Yeah,
turn
it'll
on.
auto switch. Yeah. Same thing like a motion detector,
Yeah,
almost.
it's kind of a neat trick. I haven't seen anybody else do it, but
One uses infrared and the other one uses this field.
yeah,
So,
just use this field right
interesting.
here. Yeah, this field, it picks up your whole body. Yeah, as you go by it, you know what I mean? And everybody's a little bit different. So my kids have a little bit different than I do.
Yeah.
So
There is a
it says, yeah, the field goes very far. Yeah. Sounds like high pitch. Yeah. Good experiments. Try. Tin foil. There's no static in my room. And trust me, man, I've used static a ton. Yeah, there you go. Get me a T-shirt. I need an old man builds T-shirt is what I need. Let's see, bowl hollow sphere. You know, we can always try something like that. Yeah, well, some of this stuff, man, I kind of like doing this lab because now everybody kind of gets to see the stuff that I do
Mhm.
and they get to repeat it. So
Right. Yeah.
you can take a tub of water, you know what I mean? You saw me put my fingers in there. Everything's low voltage because you'll shut everything off in the room. I I hooked one of these Tesla coils up like this on that PMP, man, and it was flying 5, 6 feet off of it. And the less breakout I get, the more field I get.
Mhm. Yeah.
So if I put a top load or something on it in order to hold that field in, it pushes it out even further. So if I took a sphere and put it down the center, like you see in all these scalar fields,
Mhm.
that's why it's going the distance it is, because it's not letting out that breakout. It's putting the breakout into something, into some metal, and holding it, so the field gets bigger.
Yeah.
It's
Yeah. Yeah. Yep.
that kind of like what's doing in the water, huh?
Yeah. The surface area of the water is humongous. Yeah. Yeah.
Now, when we talk about Wardenclyffe, do you see what I mean by you put it into the water table and then it lit up light bulbs above it?
Oh yeah. No, I know what he was doing with it. Yeah. He was exciting the Earth.
Yeah.
He was using it as a big resistor.
I think a lot of people, when they say Wardenclyffe, they think, oh my God, he had wireless energy, and they get hot air balloons
Smoky.
floating by and all that. And it's like, not really what he was doing. He's pulling the energy from the atmosphere into the ground, and then he's exciting the water. So these experiments kind of show that, though. By the way, the water does not, how to say this, outside, the water doesn't work as well without the sand. You there, John?
Yeah.
Okay.
I'm
Yeah,
trying to instantly. I'm trying to think of why.
what I noticed was I did the pond, okay, and when I did the pond, it didn't want to light up for me, and I was trying to figure out why, right?
Hmm.
And I go, I'm putting the same amount of energy in. I'm getting a very localized field. It must need to conduct with something else. And I mean, there's minerals in the water itself, albeit from the water company. It would be better if it was like well water, but When I put the sand in it, it lit it all up.
It's like striking a million little Bic lighters.
Yeah.
You know, they're all piezoelectric, right?
Yeah, well, that's what it is. All that quartz that's in the sand
Yeah.
it's somehow communicating with the energy that I'm putting in. And I don't know exactly how that works, but it's doing it.
Well, I mean, when you're impulsing it, okay, the center wire is that impulse, right? As long as you don't put a capacitor in between it, it won't turn hot. So you impulse it with the voltage, and that's the one that's piezoelectric. So,
There you
and
go.
then, so you hit that, and it's like hitting a huge tub of little Bic lighters. You know, you're getting, something out. The water is just a huge conductor, right? Basically.
Well, it is, but not always.
Well, for this energy, it is for some reason.
Yeah, for this energy, it is. Not for some of the other energies out there. Some of the other energies, you won't respond to it.
Well, or it'll kill you.
Yeah, well, there's always that.
Yeah.
Yeah, but this one, you see it. I put my hand in there.
The other energies are cyclic. This one's open, so the energy doesn't have a way to loop.
Yes.
If you provide a loop, you're in trouble.
Oh yeah, well, we're not dumb enough to provide a loop.
Right.
Well, I hope nobody else is either.
Yeah, but you're somewhat professional. I'm classically trained. There are certain provisions you have to take when working with high voltages. One-handed. Never with your left hand. Because that's connected to the heart.
Yeah.
More easily. There are things that you have to take, precautions with, but this energy doesn't seem to be like that. It's not really, it's more surface based, I guess.
So check this out. Around the pond, here's what got me. There's just dirt around the pond, right? But the water's underneath, and it seeped in just a little bit on the outside like any pond would. It's not sealed or anything. When you put the light bulb on the dirt right on the outside, it lights up bright. And that was one of the big things that told me I got the Tesla experience of putting the light bulb in the ground.
Yeah, he was using the water as a conductor.
Yeah, and then as soon as it touched the ground, it lit up brighter. Like you saw when I put it in this water right here.
Yeah.
That was the same thing it does when you go to regular ground. So as the water conducts in there and is compressed inside the earth itself, it's putting out the field, right? So the field, as soon as you touch that dirt to it, you're making some kind of a connection to it that's able to pull the energy through. That's what Tesla was doing with those light bulbs to the ground.
Yeah. Well, they were his special bulbs, though. They weren't just regular ones. They were that, and I put a picture of them. They're single terminal bulbs, so they're a lot different. This it was a test of his system, his tower, and he went out to a large patch, like a mile away or a quarter of a mile, whatever it was, and then he would try at different spots and see how it would either wane or he was expecting it would get dimmer as he went further, but it never did. It just kept getting, kept staying the same brightness. It was because the way he was electrifying the earth, it was from the surface out. It had nothing to do with miles across the surface. It had all to do with just electrifying from the surface out. And that's that messing with that plasma layer, and making it electrified or energized in that a way that you could extract it. So water is a big key to it, though.
I'll be honest with you, these type of experiments kind of tell you what's going on.
They don't lie.
No. So there's no guesswork, there's no interpreting of a patent. It is basically, this is it. You know what I mean?
Yeah.
This is what we're seeing, and this is it. So at least that's the way I see it. Because if you can reproduce what he's doing, then you've got it.
Yeah.
So and that's exactly what I'm doing out here. Is I'm just reproducing it. So we're going to do a little more fun here. See what else we got in the bag of tricks. So I did bring a knife with me. We can cut this thing in half. We did that orange, right? Let's see if we can make a capacitance in an orange. So
Is that a purple orange?
it's a blood orange.
Oh, blood orange. Oh,
Yeah, it stuff stings, man.
yeah. So like a pomegranate type bread.
Yeah, it's really red too. Okay, so what I'm going to do is I got a light bulb hooked up to one side. And I'll add the other camera back so we can see it. And then I'm going to use the orange as a capacitor.
So now you're flipping the field, huh?
I'm not going to flip anything. I'm just going to use this as a capacitor.
Yeah,
So,
that's what you're doing with the field is
yeah.
between the plates of the orange.
Well, we'll try it. So look, there's the rod down the center. It goes off right here to this side of the orange. This side of the orange right here just goes off to the light bulb. This isn't.
The orange you murdered.
Yeah. the one I already zapped.
Sacrificial orange.
So let's see. We have 12 volts. I have a distance apart. My light's already on, right?
Yep.
So I'm going to take this orange.
As soon as you touch it, it goes out.
Oh yeah, my phone went out with it.
Your capacitor sucked up all that energy. Is it shocking on that side?
No.
Okay.
Now I unleashed the light bulb.
It's pretty bright for 12 volts.
Yeah, well, it's got the power of the orange. You can't discount that. I mean,
Citric acid, right? That's the booster.
yeah. Let's see, how far can I get it? It's still lighting it up over there. It's a lot less bright. You can see that. But it's still lighting it up. Put it next to it. You see, putting two fields like that together, it's just capacitance. So it lights up bright right there when they're close to each other. We simply move them apart. Now less bright.
Well, less inductive coupling
Yeah, it's just
at that point.
less energy in there. Let's see if we got another one. Take an orange one.
Probably losing a lot of the energy through the space there.
Look at that, right between it, bright
So-
as day.
So wait, take it out.
Hmm?
Take the bulb out. So the other one did get brighter.
Oh, it got brighter when you move them closer together. Yes.
All right. No, I
What,
mean
was
the
it-
bulb. When you put the bulb in there, it gets dimmer, right?
The other one.
Yeah.
Okay, so we'll take them both in the camera shot. Can you see them both?
No, it doesn't. Oh, it doesn't change it at all.
This one.
Oh, wait, a little bit.
This is outrageous. It's like a lightsaber now. Look at how bright that is.
Yeah, I know. That's real orange.
But what I'm trying to say is that's what happens in capacitant plates. That's how they work. And I don't care if it's an orange. I don't care if they're bifilar coils. That's how they're working. The area in between has a lot of energy. And then you put them closer together, and that thing just gets brighter. It's just a simple capacitor. And it's just
Well,
a
it's an
delta
air
voltage.
it's an air capacitor, but
Yeah,
not simple.
yeah, it's basically what it is, using the dielectric between the two.
Mhm.
So that's what I mean on the Wardenclyffe. We saw the two bipolar coils, right? That's all they're doing. The same thing I just did right here. Move them further apart, less energy, put them closer together, more energy. And then you start to get, I don't know if you can see this, but there's plasma in there.
Yeah, I know. Yeah, that's the crazy thing. Yeah, it's breaking out on that end, isn't it?
Let's see if it's doing it on this one. Not the other side, just the side it's connected to.
Right. Because it's being sucked that way. It's being sucked all that way down.
Yeah,
It's actually jumping across the oranges to
yeah.
your center rod.
Well,
And
that's
then,
what I mean. When Steinmetz talks about the dielectric, that's exactly what we're in right now. That's what we're fooling with.
well,
It's just,
there are different levels of it. I mean, our
well,
atmosphere is different density at different levels. So
what I'm talking about is like in like lines up there on for your house. That dielectric between them is the same thing we're doing here. It's just his is at tons of voltage, mine's at very little voltage.
right, yeah. Well, it doesn't really take much from an electric field. I mean, people
So,
were arguing that it takes a lot to break water apart, and I was doing it at 0.6 of a volt. It was
yeah, no,
slow, but it was still working.
no. Yeah, see, look at that. Likes all the different colors.
Like low level electrolysis is a real thing.
Yeah. Oh no, you could break metal apart with an anode and cathode at what 5 volts.
Yeah, it doesn't take much sometimes,
Yeah.
depending on the energy, I guess.
Look at that. That thing's awesome.
So just a FYI, I put that picture up of his single terminal bulb. That's the one that you were talking about. It could tell
Yeah.
when humans are around.
You set down my phone and we'll change the screen real quick.
Not to, you know,
There's radiant.
that's the single terminal bulb on the bottom there. See it?
Okay, and this
On
one,
both of those? On both of them. That's a single terminal bulb. Then on the other one,
it's got one direction. I'm seeing. I can't see it very well right here.
it's below the tattoo of Tesla Universe.
Oh, I see it. Okay.
It's figure two. That's his single terminal light bulb that he called a single terminal light bulb when it was actually his emitter to spread the charge out so that you wouldn't get corona breakout.
It's got K written right there. Is that just a letter signifying something, or?
That's it's just a single terminal. I think
Okay.
he used like carbon buttons. It turned out it was like a baked carbon button. And it would create these rays, and your center wire was connected to the one side. It would create the rays at the other end. If you pointed at a piece of copper and you hooked it up the way that circuit shows below it, you'll get energy. Now, that's the way he explains it in that picture. That's one way to do it, one method. But I think he was doing the same thing with his Tesla tower. He had those single terminals on the top so that it wouldn't break out. Because anytime you break out, it's a loss.
Well, yeah, I keep telling that to people.
So that breakout on the end of your secondary there is a loss.
Well, I'm thankful that it's breaking out today because my computer would be shut off right now.
Yeah, I know. Because the field be huge.
Yeah. I mean, look, there's no joke, man. My computer usually, it's like, 10 feet away now. It generally sits about 20 feet from where I am.
Yeah.
And I can still turn it off.
Yeah.
And what it was doing, by the way, is it goes through every web page and shows you every single one of them that's open.
Yeah.
And then it may open or close other ones. That field, man, it interacts with your computer and your everything in there. Not just the saturation of the capacitors. It'll mess with your MOSFETs, transistor, whatever you have in there.
Yeah. Coils especially. Yeah. Anything
Oh
with a
yeah.
core in it, power supplies, things like that. That's the whole thing about it. Once you destabilize that, that's all bets are off.
Well,
It thinks everything is high, and then it just says, "Well, I'm broke."
but in order to mess with the web pages, it must do something to the MOSFET or transistor in there because it's turning things on and off, like clicking
Yeah,
buttons.
it's like a threshold. It's noisy, and when it hits that threshold, it goes above it. It does something weird, and then it stabilizes, and then it goes above, does something weird again, and then stabilizes.
Well,
So it's
think about this though. They had that UFO that went over the missile silo, is what they say in the story,
Mhm.
and it was over there turning things on.
Yeah,
And this is why. This
yeah,
type of energy right here is
yeah,
exactly why.
yeah, yeah. It will mess with things if you don't properly do it.
Yeah. Well, I don't think they were shielded either. I don't think they expected anything like that to happen.
Nobody,
So.
our power system's not even shielded, dude. If the sun decided to have a CME, it would be gone. All the transformers in this world would just boot, and then it would take like years to get them all working again because there's so many.
Yeah. Yeah, I think this is a neat little experiment, man. It's kind of a twist on things. I mean, you can use coils for this. That honestly, man, it's I like using the oranges and stuff. It just paints a point. It's kind of like, dude, this is so ridiculous that it's kind of obvious what it's doing. There's
Yeah,
no getting around it.
yeah. Well, I mean, I guess it's all about capacitance. If it was no capacitance, there'd be no induction.
Yeah.
You know, if there wasn't a space in between things, there would just be conduction, and everything would short out. And I wouldn't be able to see you, and you wouldn't be able to see me, and nobody would be able to sense anything. So
Yeah. All
that's the
right. So
key to it all.
here's my fun little experiment. I'm putting my camera back up there. I'm going to use this burrito to light it up. I just love the idea of it because it's ridiculous. It's stupid. It should never
Nathan's
happen.
Nathan's getting hungry.
That's right. Joe had me on this diet trying to kill me.
This is how Nathan cheats. Let me just touch it. Let me play with it, man. Let me burn it.
Yeah.
Oh,
So a little bit of a breakout.
did you crash your computer again? Yeah, I think he did. Yeah, he cranked it up. That poor computer. It's getting assailed today. So yeah, it's all the usual. He didn't actually show the light bulb. Um, he'll be back momentarily. He's taking a break. Yeah, yeah. Well, that's how it works, right? Fry it until it's gone. He should have a backup though. I gotta talk to him about that because sometimes you can do permanent damage with an intense electric field. It's a success. Can I talk about transistors? What do you want to know? Transistors are like it's even though they say it's in capacitive control of a flow of current. There's a lot. It's still a lot of straight conduction through that channel. You know what I mean? So even if it was induced, to flow across it, it's still straight conduction. Yeah, yeah, it's probably cooked by now. Depends if you shut it off. Well, no, the Faraday won't because it would be grounded. But one of the neat things about this stuff is it's self-reflective. Okay, so the meaning like it follows kind of like static rules. So if you have two positives, they tend to push each other away, unless it's well, if it's driven. But if it's like natural, like in like two particles, they'll push away to a certain point, but then will actually stay together. So that's how matter condenses. And matter likes matter because it resonates with itself. Tends to, like gold is gold. You know what I mean? Like the particle. You can have different forms, but it's still gold. It has a frequency to it associated with it. Well, we'll see if Nathan comes back. Hopefully he will. Oh, whoa, oh, there we go. All right. He's back. Da-da-da-da-da.
Oh man.
Back in the saddle again.
Yeah, that thing is just too crazy. All right. There we go. We're back on.
And he's like, he will because the live stream didn't end. Well, yeah, he's got to shut it down. It's on a separate broadcast.
Yeah, somebody's got to be in here, man.
Yeah.
So let's do this. Let's unhook this bad boy.
As long as I don't leave, it should stay open.
Yeah.
I guess that was a good idea, right?
Yeah.
Have me come in because that would have been dead air at that point.
Oh yeah. Well, Nathan over here playing with his
Yeah.
stuff.
Did he eat any of it? No, it doesn't look it.
No, I didn't eat any of it. All right. So let's take this out of here.
So have you noticed? Have you tried different rods to put down?
Yeah, they all act differently.
So like copper as opposed to brass, as opposed to carbon?
I don't like using aluminum.
Yeah, aluminum is voltage sensitive. That's why. It's very piezoelectric too.
Creates bad things sometimes.
Yeah, it can. It's a radiator, so, and it's crystallized radiator, so.
Yeah. You start messing with aluminum in the wrong way and defining fields, and you're going to end up shooting stuff across the room you didn't intend.
Yeah. Well, that's why it was like copper or, carbon. Carbon seems to be pretty stable. The reason why I think aluminum is unstable is because there's water in the air, and when you energize it, it reacts with the water in the air and destroys itself.
Sorry, give me 1 second. I'm pulling my ZBS out. People are always interested in that thing. So
yeah.
And I can change the capacitance in it. Hopefully it doesn't shut everything off.
Is that a homemade VVS or?
No, it's just store-bought, Amazon.
Oh, okay.
And I change like you change the capacitors on it. Usually I got a set of high voltage capacitors.
Yeah.
Just like standard Tesla coil capacitors. On this one I have Ian's cap bank on it.
That's what it meant, Jabber.
Yeah. So it's gonna adjust the capacitance in it just by flipping switches.
It's because of the aluminum oxide. I was gonna say that, but whatever.
Okay, 1 second. On.
They were really salted your burrito. Yeah.
You can see that as soon as I change the capacitance in it, You see the difference in the light?
I hear it too.
So I'll turn them off or turn it back on. So I got too much in the system now.
Yeah. You can hear it change the frequency.
Yeah.
It's very high now. Now it's low. Medium. Now it gets higher the more you move away.
Oh, it just broke it.
Yeah.
See, that ZVS compensates for that. Excuse me, the Slayer does. This one doesn't.
Right. Yeah.
You have to manually adjust it out.
That's
Yeah,
more like we would hear in radio. That kind of interference.
Well, it makes you wonder. The guy says he ran his vehicle off the power of a radio, right?
Yeah.
So if you had a pickup that was tuned to the same frequency, you probably could pick up some energy. I don't know how much.
Oh, minuscule at best. But if you're using that to run something else,
Yeah,
that
something that
maybe
multiplies it.
yeah, that is an amplifier. Then
So let's take a look real quick. I'm just going to turn the field off. That way, hopefully, my camera will set. So there's Ian's cap bank right there. And there's the ZVS right there. So all we're doing is these two leads right here is you put a capacitor in between the two.
all right.
And then these two, the one on this side right here always goes to the clip, which goes higher up on the coil. Right there. Then this other side always goes to the bottom part. Then your ground now gets connected to either outside or to the ground here in your wall socket or whatever you're going to use.
All right.
So this thing is cool, the cap bank, because now we can just change the capacitance of it any way we want. So we'll just bring this thing up.
Well, you'd be surprised how many ham operators are probably around them, and they're probably bitching right now.
Yeah, you never know.
But this stuff actually sounds like the stuff that ham operators would hear from ionospheric interference. So, like the sun happens, they would hear a bunch of this. It would interfere with their long distance communications, though.
Yeah, all right. So we got it set. I think we're okay to try something. Now it'll have to change completely when you do this again, by the way. That's what sucks about these, man. Oh, wow, I broke the top. That's what I got. I probably glued it when I started heating it up.
Oh,
All right.
it's whatever.
Just build a new one. All right. We'll try the Burrito power now. Now that it may not shut off my computer, hopefully.
Yeah. Just don't ramp it up like you did.
Well, sometimes, man.
You went too hard on it.
I may be way out of resonance.
Sauce
too.
that thing. Sauce it up, baby.
Yeah, I think I'm way out of resonance on this thing. There we go.
That's coming up.
Now let's leave it right there. It builds right to the burrito. It doesn't matter how many burritos I attach to it. It'll still do the same thing. Okay, so now, because we had to adjust for the rod when we put it in there now, and the light and the burrito, because I don't have anything to break it right now. Let's try another one. Might as well. Packages, man, are getting better and better.
What was happening when you put the rodent coil in between that?
It breaks the frequency. So it stops it from changing frequency on you. So everything after the rodent coil would stay the same frequency. Everything, when you don't have something like that, you don't have a saturated field, it'll continue to change it on you.
Really?
Yep, it'll keep changing it on your coil, and you keep wondering why is this doing this, and get all irritated with it. So there you go. There's 2 burritos. There's 1. There's 2. I think it.
And your phone hates it.
Yeah, it's just on. Yeah, my phone keeps. It does not like any of this stuff.
It's the Wi-Fi on it, probably.
Yeah, it's like had too much abuse in its lifetime.
Yeah. You're overdriving the signal. That's all.
Yeah. It's just pretty interesting, man, that it goes through this stuff. So I bet you if I stack it, guy's just playing with food on live air, huh?
What's up, Coat?
Let's stick it on the bottom of there. Now let's see if it works. 2 burritos, 2 oranges, and we're
Double
coming up the
decker.
bottom. And of course it does.
Yeah, sure.
It's just water in the burrito is what it's reacting to. Anything that's got the liquid in it.
I'm giving it all I can, sir. She's lit up like a Christmas tree.
Yeah.
What's up, Coat?
Yeah, the one thing I like on this is this switch right here. You put it on your negative and you just turn it on and off. Makes it so much easier to operate. Check the chat, see what everybody's doing.
So anyways, you showed the patents there, but that last one is a picture of the light bulbs.
Oh, it's just a switch. Basically, you're breaking your negative on a lot of this stuff, and that's the switch you use. So on your, from your power supply into your ZVS board, you break the negative with a switch. And what it allows you to do is keep the power off to this stuff until you need it. And then you can turn it on and have instantaneous power. Sean showed me that trick, and it worked great for every ZVS board that I've used. Yeah, most people just break the hot. This one just breaks the negative.
Scottish way is right. One hell of an engineer. Predicted invisible aluminum before it was even a thing.
Nice. Yeah. Yeah, just use a regular 110 volt switch. You don't need a DC. I don't use them. I use AC switches. They're a lot easier. Wow. Yeah, we're lighting up food, man. Just having fun for the day. Daisy chain the burritos. So we can. I mean, look. This
Maybe
thing,
it'll act like a battery or something.
No, hold on. Let's see.
Is there a plus and negative side to the burrito?
I don't know. That's funny. Let's see. We got a couple of them, so let's just give it a shot. Okay. Try to keep them away from each other.
Did you make any progress in your sympathetic resonance?
With the different coils?
Yeah.
With the different coils, I did. The small to big.
Does it seem to be limited?
It's tuning inside of tuning.
Okay.
So it gives energy. If you light up the small coil, well, that burrito broke. What it's doing is it's finding the resonance point in the bigger coil. So if I took this coil right here and I cut it down to here,
Right.
then it finds that spot in the resonance. So it's not as powerful as it would be coming out of the Holt coil, 1-to-1,
Right.
but it is powerful. So
Like a single wire connected to it would be
yeah.
stronger.
So as you get each one in there, it's picking up a different part of it that it's resonating at. And by the time you get to the size of the big one, it puts out a pretty good field. So the less energy is the higher frequency, which is the shorter coil. So it kind of told you that as soon as you started working with it right away.
Yeah.
So
Are you going for a 6-pack there? What the heck?
I kind of, well, we're just going to see if we can oscillate that or turn it on based on that coil. We're just going to clip it right here to the.
Just get coat to hold on to the end of it, okay?
Yeah. Get him over there with that chicken that he was eating that day, man.
Have to hold on to the chicken.
Yeah.
See if it cooks it
A nasty chicken.
through him.
All right. We'll put the light right next to it and we'll just see if it turns on. May need some tuning.
Nothing wrong with ozone flavor burrito. Yeah.
There it goes. There it is.
Yeah, you can hear it too.
Yeah, it
Oh,
just
and then
oscillates
it
right through it.
quieted it right out, but I think it's because you moved away.
And all right, let me turn on the phone again. I'll show you all the burritos. And it doesn't matter the distance, man. Put them at whatever distance you want. It literally will do the same thing.
No, I think it's you that's changing the frequency. Because you walked away and it got really quiet.
Yeah. See, look. There it is connected there. There's the one. There's the second. There's the third.
Put
The
them
fourth.
in a pyramid shape.
Okay. Well, I will. You got to go to the primary. All right, hold on. Let me turn this off real quick because I am messing with the field. I don't know if I can get a pyramid. Well,
A diamond's good, I guess. It's
yeah,
like
go
two
with
pyramids
that.
stacked together.
See what they do.
Yeah, I think it's picking up him. It's changing the frequency. He's getting a beat frequency from it. He's reacting with the system. Just think, though, if you had two of these coils and you just had your hands and moved them around, you could actually steer something with it.
That's kind of the point, isn't it?
Like two balls, like they showed on all the alien movies. Put your hands on the balls and move them around.
Man, I'm going through this whole thing and I don't have it. Wow. Do I have it on? Yeah, I have it on.
Is it shorting out? Do you got them touching?
I don't know.
Maybe it's super cancellation.
Let me see.
Oh, yeah, I hear it. It's working.
You hear it?
Yeah.
It must be a low resonance point.
Like, go back like a few on the first row from the bottom.
Okay, that's going to blow them off set if I keep going.
And I wouldn't, Ulysses, okay?
Yeah, I can't hear it. Oh,
they would be my balls, okay?
Hold on. Let me just, I think I had a wire out.
Yeah, right. Back up, down. Yep, right there. There's low. And if you go one more below that, it will go high. Yeah, low, low. It went really low.
No, it's way out of resonance.
Yeah.
Way, way out.
It's like just barely picking up something. Maybe it's just interfering too much with each other.
Yeah, maybe. I haven't heated up the MOSFETs yet. Huh.
There, there.
Yeah, well, it's picking up probably the low. It's not picking up the one I want.
Yeah. It's detuned itself to a point where you can't get to it.
Give me a second. I'll get there.
Well, maybe it does have a lot to do with it is kind of forming like a loop, you know, in the middle there. So
There it is.
immediately, yeah. Now I see why you did the coil that way. It's pretty good.
Well, I adjusted it on the coil, and now I got
Yeah.
it in resonance.
Yeah. Works good.
Yeah, there we go.
That's
how
how
it
finicky it is. Imagine trying to keep that in phase, you know.
Well, that's what I'm trying to tell people. It's they want to tell me everything's wireless power to the air. It's just you're going to have to get an enormous field to do that.
Well, sure, yeah, but I mean, it depends on, you know, your element, right? Your antenna element.
Yeah.
Think as grand as Tesla and use the whole Earth.
Yeah. Well, that's what I mean. It's kind of pointless to put it out in the air, though. I mean, if you add a tune just a little bit and your body capacitance and you figure how many people are on an airship, you know what I mean? It would just change it too much. And there's ways to shield things, don't get me wrong. But it's so much easier just to do it to the ground. It's easier to pull in atmospheric energy like a Corona motor and tune it.
Yeah, well, with this impulses, it's a lot easier to transmit through the ground. So it's like sound waves, kind of like.
Yeah. You kind of have to, the core cannot be hollow when you want to tune it because there's too much variance as soon as it is hollow. As soon as you get a solid core, it doesn't have this problem. So if you think about what Tesla did with the wood and he put it down the center,
Yeah,
it's to stop this effect.
it depends on what type of wood it is. Yeah.
Well, look, I could do it with anything. I could take another piece of PVC and put it down there. And
It acts differently with different materials from what I see.
I
like
just did the test yesterday.
Ceramic works different than wood, and wood works different than iron, and iron works different than, you
But
know, glass. And
But what I'm saying is it's filling up the cavity on the inside. What the reactance is doesn't really matter compared to how you're filling up the cavity. Once you fill up the cavity, then outside of it, the frequency doesn't change as much, it's more stable. It's very much the air on the inside that's having the problem.
yeah.
It's creating that variability.
You mean like the oil displacing it?
No, I mean, how do I say it? If I took another piece of PVC, I took a number 2 coil and I sat it right over it, right?
Right.
It'll change the frequency, but then when you adjust to that, it's more stable.
Right.
So anything that I put it over it that has mass to it, regardless of what it is, stabilizes the field. Therefore, anytime you get to a core in a transformer, it's a field stabilizer.
Right.
Now, it doesn't matter what the core is. That was the point here. It doesn't matter because it's just stabilizing the field. So when you have wood down it and you wrap wire around wood, then that wood itself stabilizes that field. You don't get all this variance that we're getting here in this open core because there's nothing in there but air.
What about crystal?
I have no idea about crystal. It's not the direction I'm going. I mean crystal may cause a secondary reaction, but it would still fill it up.
I mean, would it be a different reaction though? I mean, you said basically it would be the same.
Well, are you activating the crystal or not? Because there's no water in it.
I don't know how a crystal reacts in this kind of energy.
The crystal,
that's why I was asking.
Crystals basically run high voltage right around them. And because that you can see through a crystal. It looks like it's lightened up, but it's not. It goes right around it. So it's the same thing here. It wouldn't react at all because you're not even contacting it with the correct field. So it's like two ships in the night. It won't even see it. It basically just uses mass.
Right. Okay. All right.
So,
So
I
just a
mean,
dampener, basically.
yeah, that's basically what you're doing is you're bringing down the frequency in
Right.
anything that you put down the center. This rod right here can go 100 kilohertz down as soon as you put the rod down on your
Right.
ZVS immediately. So it goes right out of tune. So when you start putting bigger things in there, it changes it as well. When you start doing it, the secondary itself slows down and you're getting more heat out of it. So if you want more amps out of your Tesla coil, you just have to take the field in the center and put a bigger mass in it. Get it where it doesn't have the ability to go as fast as it does because you can't use the air in it. It now has a hindrance to it and it stops.
I wonder if there's a. Did you try carbon yet?
I didn't put anything destructive down any of these things.
Just regular carbon. Like
Mhm.
a pencil.
I tried to run the energy through a pencil and I got sparks.
So you hooked the pencil to the wire
Mhm.
and then put that down the center.
Yeah, I didn't put it down the center, but it got sparks in between it, like it was on both sides.
Oh, okay.
Yeah, like I said, I only put the rod down there, and then I'll put like a number 14 gauge wire on there with insulation on it,
Mm-hmm.
and that works absolutely the best. So
14 wire with insulation.
yeah, just the regular wall wire,
Okay.
stuff you wire your house with. So the reason why is it takes a while to get to the insulation, and then when it does, it hits a mass of copper in there. So it'll slow it down to the fact that it's not going to burn you like this one does. It works a little bit different. It makes the water energy experiments much easier to deal with.
I wonder if copper is more permeable to this stuff. Like it goes into it easier. You know what I mean? It seemed to be more like current driven. Like if you take a big copper coil, thick, big copper coil, and you oscillate that with a high frequency, and you got a capacitor on there too. I mean, you could bring it down a lot.
Yeah.
I just wonder how much you could get out of that transformation there. What about fiber optic wire? That's light. Well, I guess light is electromagnetic, but I think it's more subtle.
Yeah. Sorry, I'm trying to catch up on the comments and see what people do.
Yeah, I was answering people here and there.
Yeah, everybody loves that mercury. I don't play with that stuff.
Yeah, mercury's a little toxic to play with, especially with electricity. It tends to vaporize a little bit easy. That's mercury, yeah. Gallium, mercury. Well, I don't know. Gallium's not really at room temperature. It takes your body heat, basically.
Yeah. How do I determine it? On this one, you can use radio frequency to determine what your number 2 is. That's how I know how to break it down into individual parts. I just find the resonance points of each one. There's 4 of them in that coil. So there's 3 different sizes, and then the coil itself, so the big coil itself. So that's all 4 that are in there. You can find that during radio frequency. You can use an LCR meter, which takes the total, amount that goes on your number 1 coil, and then put in the capacitance based on that. I like to adjust it around and play with it because sometimes I want to be in resonance or out of resonance, depending on what I'm doing. Like right now, I blow up my computer when I'm in total resonance. And then I like to be a little bit out just so that we don't kill everything in the room. So, yeah, I find this funny. You know what I mean? People go, oh, man, you couldn't turn off my computer. Dude, I could fry your computer if you put it in
Yeah,
the room.
I'll sit right outside your house and eat.
Yeah.
I won't say that.
No,
But it's people don't understand how open our electronics are right now and susceptible to things like this. It's probably the reason why it didn't go very far so quickly because we didn't put the protections in that we should have.
yeah,
Because it was about how cheap we can do it instead of how well we can make it.
yep. These things actually stop pushing out the field at a distance when you get the breakout. Once you get up to the breakout, usually about 5 feet, and it becomes a hindrance. There's a wall right there,
Hmm.
and it'll stop. And then once you take away the breakout, man, does it push. It now starts to fill up your room. So, yeah, that breakout has a lot to do with how far it goes. You can't hold you can't hold compression with the breakout. It's there. It won't stay. It keeps flowing it out. You know what I mean? In order to create that compression the way you need it, you have to stop that. So, yeah, it's kind of interesting, man, how some of this stuff works. I never thought it would go through a burrito, but I mean, think about it. If your burrito lights up at what, say 3 feet, now think of Edwin Gray again, and now you're going to put that in a field that it can't get out of. I mean, get out of the burrito. It can't get out of the mineral oil. So you put that in there, man, and you're compressing it. Man, if you'll flip that, and you got yourself some energy.
Yeah.
So that's kind of why we run the test, man. See what everything actually is versus what everybody thinks it is or writes down about what it is. That's the whole point of doing the test, because not every patent tells you the truth of what's going on.
Well,
Like,
it's a general explanation. Yeah.
yeah, I mean, look, if I were going to write a Tesla coil patent, I sure as heck wouldn't tell you anything about the water. And
Well, you know that KFC didn't write their secret sauce,
yeah,
in the patent, okay, and then put it into public. So
well,
there are
yeah, but
things that they can keep as trade secrets.
that's what I'm saying. There's so many things that put you in the wrong direction.
Yeah.
One different way of looking at it, and it sends you down the wrong path completely.
Mhm. Yeah.
So, yeah, they didn't
Or
put everything.
ignore a total avenue of physics, and you lose half of everything.
Yeah, you do.
You
And
lose half of all the free stuff,
yeah,
or
well, as soon as
quote
you,
unquote free.
well, think about it. If you read Steinmetz, what did he do? He had to take everything out of that energy in order to make it work the way he wanted it to work, right? Well, that basically means if you took what Tesla did and then took away what Steinmetz did, you'd know where all the stuff is, right? Because all the special stuff Tesla had and all the stuff that was boring and ordinary was Steinmetz. Then you get down to really what you have, which is all the extra free energy and stuff like that you get from these things. Because, yeah, how do I say this? You put this energy here into the rodent coil, or rodent coil saturates, you start to pull the wires off in energy. Then you could, you know what I mean, pull it until the saturation is gone. It's no different than a jewel thief.
Yeah.
All you're doing is saturating the core.
Mhm. Yeah, and then letting it flow through it, just like the Floyd Sweet device.
Yeah, pretty much it. Well, if you can create a magnetic field without having to pay for it, which is I think what that whole MAG was about, is you create a magnetic field without having to pay for it, then the field that you draw in is the dielectric it pulls into it instead of pushes out, because the magnetic field's in the inside already. So it's pulling energy from the outside in. It's working as a suction device. It went in reverse. I don't think people understand that. They think a magnetic field's only one way. It only pushes out. It's not true. It pulls it in.
Oh, yeah, it oscillates. The magnetic field is just that. It just oscillates.
Yeah.
It's in constant motion, or else it would just die off instantly.
Yeah, I think that's why people come out and they have over unity devices because they realize that there's two sides to it. And right now we're only getting the one side and we think we know everything and we don't know anything.
Yeah. Well, we know the half that they could hook a meter to.
Yeah, that's the
You
hot
know,
side. Yeah, well, yeah, every
so
day.
that they would just wanted to create an income stream, and that's what they did. They didn't care about anything else. And then it's just a matter of controlling the information. You know, simple.
Well, I agree with that.
And
Hey,
you want to hide the secret, leave it right in the open.
well,
Nobody will
yeah,
believe it, right?
yeah, big time. That's why I wanted to do the water experiments, get people the coil in their hands so they could do it because this is a different reactance.
I think it was something that he learned. He did a lot of. He was really book smart. I mean, Tesla really liked to know the anomalies in life too. So the pyramids were kind of a thing with him, and I think that kind of gave him the idea of the fair weather potential and how to harvest energy from the atmosphere.
Well, yeah,
Is
that's what
that
they
it was
do.
is that it was already done,
Mm-hmm.
and he realized it, and he was like, "Wait, what okay." Let me do an electrical analogy to that. So he made the tower, and I don't think he fully discovered what happened. I know that he had an accident one time, and that really caused a lot of problems with the generator that he had donated to that island that he moved into for the tower. Was it Long Island or something like that, or wherever it was,
Hmm.
or is, where the tower is located? And he blew it up, because it backflowed into it, because he didn't really understand everything. I think he kind of underestimated it. You know,
Yeah. Well, I mean, think about it. If you're pulling in energy from the sky, putting it in your water table, you do the same thing with the pyramids, and the pyramids are everywhere. It basically means the Earth was a much different place back then.
oh yeah, yeah, there's a growing body of evidence that there were pretty cataclysmic times and times where probably the Earth needed help. Because the sun just beat it up. Uh, it happens all the time. CMEs happen all the time, and it's just like the sun punching us.
Yeah.
I mean, energetically, and it has an effect on everything: our weather, earthquakes, everything. And all this energy is just sitting there.
Yeah, it's available to be used. That's for sure.
Yeah, well, it won't be unless we realize it's there and get rid of it. If we start using it, if we even take 20% of the energy that's available there, which would definitely cover our entire planet's energy needs forever,
Hmm.
because it doesn't end as long as the sun is going. You know, at least for in our eyes, it would be forever. But I mean, and that wouldn't even be touching it. It would still be kind of chaotic. When the sun gets out of unruly.
Yeah.
It's
Well, I agree with that.
this is
I
something
mean,
that we could be helping with, and we'd not because people want to hook a meter to it.
yeah.
It's
Well,
ridiculous.
I agree with you. The whole meter thing is a bad idea.
Yeah,
So,
there's some things that should just be. Listen, if I'm born here and I don't have a decision on whether I am born or not, and I have to be here, there should be certain rights, and right to life, liberty, and pursuit of happiness is what America's about. Supposed to be. It's not what it's turning out to be, but
yeah. No, I
we'll
understand.
we'll see. But I mean, We got to start working on this stuff because there are things that are happening to our planet that we're not going to be able to control if we don't do
Well,
things
yeah, I
about it.
mean, we're not even close to preparing for a next cataclysm.
Well, I mean that's the whole thing. I mean, we're always preparing for the next storm or the next earthquake, or there are ways that we could actually preempt that and just take the energy out of the system, and it
Well, I
wouldn't
agree
happen.
with that, but what I'm saying is we're like every one of those movies. As soon as there's a big wave, we're screwed. We didn't prepare for it. We didn't build the shelters for it. We didn't even
Yeah,
try.
yeah, yeah.
You know what I mean? We're all just the little ants on the ground getting squished.
Well, that's business for you. They don't care about the future. They only care about right now. So
Yeah.
yeah. No, you want to know something? It ain't gonna help them.
Yeah.
So
Well, you
the
can't hide
elites,
from a cataclysm.
elites can quote unquote think they are prepared, but what happens is not going. It's going to affect everyone. This is a world event. This stuff has happened before. Will always happen. There ain't nothing you can do to change it. It's just how you write it out.
Yeah, or build yourself out of it. I
Yeah.
mean, go to space. You know what I mean? Maybe it's worse out there. Who knows?
You
But
get served lemons, learn how to make lemonade.
yeah, got to try something because what we're doing isn't going to work. I mean, there's whole cities would be underwater before we knew it.
Yeah, well, I mean that's just the nature of the sun and all that. And we get helium plasma or hydrogen plasma from the sun. When it mixes with oxygen, it creates water. We're gaining water and faster than we're expelling it.
Yeah, what does it say right here? Huh.
So there isn't much
Uh,
we can do about it.
Within 10 years, we'll be fine. Yeah, well, maybe we care about our kids. Uh,
I
build the
I
way out of it. We could.
I,
Absolutely could.
I don't like thinking like that. Oh, 10 years, we'll be fine. Don't worry about it. We kick it down the road. Then 10
Yeah.
years comes along and we're still in the same situation. It won't change unless we do something about it. Well, yeah, it's kind of simple though.
Okay, so you could say a Faraday cage. Uh, the problem with this particular energy that goes in the water right here, if you do it right, a Faraday cage won't hold it.
It conducts to the metal and energizes it. So you end up passing the field right into the inside.
Well, it goes right through it.
It's
I,
an exciter field.
yeah,
It
I've
excites
had
metal.
this thing covered in metal and it goes right through it.
Yeah.
It doesn't even care that it's there. It may heat it up, but it goes right
It
through it.
probably
Uh,
will end up working like a lens, more like if you designed it like a lens, I bet you it would work
oh
like
yeah.
a lens.
Well, like AC is on the Tesla coil is great for a Faraday cage. That's
Yeah,
what
that's
all. That's
RF.
what. Yeah, you're going to see that everywhere you go. They're all using AC. They're not using DC. It makes a different type of energy.
Well, it's easier to protect. I mean, they can sit in a Faraday cage and not worry about it, you know?
Well, that's what I'm saying. Faraday cage, because people get confused. They go, "Oh, well, I saw a Tesla coil in a Faraday cage." They
I
don't.
um
They're not
I am
realizing the energy different.
I am of the opinion that if you created a just a cardboard piece of cardboard and you painted carbon black, uh, a base paint of like sealant paint, carbon black, sealant paint, carbon black, sealant paint, that carbon shield would protect you against the longitudinal energy.
You think so?
Yes.
I'll try that. So carbon black and put a primer on it.
Layers, layers,
Yeah.
layers of it. Okay. The layers, the capacitance between the carbon is what is going to protect you. Remember, this energy likes capacitance. It will stay in between it.
Hmm. You're
So
creating a trap. Is what you're saying.
yes, remember your device you're building, the ball, the layers. Remember,
Mm-hmm.
the layers will trap that hot energy field. You'll get a whole layer of hot energy. You get a whole layer of cold energy. You get all these alternating layers. and it's the same thing.
Hmm.
It's the same way to protect it, because I think this is kind of like the same energy they had back in Egypt with the pyramid. So, and they used to have, they used to go through rituals and all that stuff. The guys that run the temples, the priests and stuff. So they would put oil on you, and then they would do incense, right? And then they put another layer of oil on you, and then they do incense. They put another layer of oil on you, and then they do incense. And I'm telling you, it made a carbon suit, and it protected them against the high charge in the ark.
Really?
Yeah.
That's cool.
And then they used the ark and sometimes they would use it in a bad way as a weapon. And those stories are there. You can read those. I'm not going to go through it, but they're in the Bible. These are not, so I'm not hiding anything. I know a lot about this stuff because I did a word study on the Bible when I was a kid. Between the Greek, the Aramaic, and the Arabic, or no, was it was Greek? The King James, the Greek, and the Aramaic Bible, just to see the differences between them and the translation differences. But all right,
funny.
come on. All right, easy. All right, easy there.
Oh, you get diddied with the oil.
Yeah. Get easy there. That's
He was trying to protect him.
a good joke, though.
That's a good one.
Well, yeah. I mean, I think this is probably there are ways, and I think that's the way they're protected in cables as well. Remember, I was talking to you about doing shielding. Don't connect the shielding to ground. Connect it to a capacitor and between the hot and the capacitor. And the hot will keep the capacitor charged and keep the plasma within the two. And it'll keep it around the center wire. It's like a plasma conduit. You're losing hydrogen way faster than we're gaining it. So
Marlin
zone
size of somebody.
Well, I mean, it's that way now. I mean, it wasn't always that way. I mean, we've done a lot of damage to our atmosphere with like the coolant there. Was it? I don't remember what the coolant was, but it was eating the ozone layer. Big holes in it. And of course, the sun it's not staying the same. It's changed. It's changing.
Yeah.
What do you mean the contrary holds no secret? It's true. I mean, everything's available through that. If that's what you mean.
Wow, I can't really see the screen at all. Oh man. There
Is
we
it
go.
so tiny?
Yeah, getting old, man.
Yeah, what do you expect? Can't stay young forever.
Oh.
Well, I don't know if that was the cause of it, Patricia.
What was?
Yeah, well, HARP was a way for them to experiment with playing with the ozone, with the ionosphere, which you have to call in another brilliant idea by people who don't understand what they're doing. Well, yeah, I guess.
Hold on.
Well, they're saying that it's speeding up right now, so I don't understand what the difference would be. If it's speeding up right now, the days are getting shorter, then taking speed out of it would return it back to regular time.
Man. Okay, sorry, I'm reading this all wrong. He said it's got a hemopole motor.
Homopolar. So it's a homopolar motor.
It said because it said pole. I'm thinking I was reading in my head homopole. There's a homopole
You're like,
motor.
what?
And I'm going, that doesn't look right at all. And he's trying to make a serious point, so I didn't want. Yeah, good luck with a homopole motor. You're gonna get the wrong end of that.
And also, Marlon, I don't think that's 100% what is running the whole thing. That's only part of it. So if you take out a part of that, you're going to have a lot of
The hole in the
yeah.
ozone by the 80s. All that hairspray. Ah, that's funny. All big hairy 80s chicks.
Aerosol injections. Well, they shouldn't be doing that. I don't think they should do any of that crap.
Oh.
I don't know, Daniel. I think we kind of think the same, man. I think at the center, almost all bodies are plasma. It's just whether it's excited or not, you know. And ours is
Oh,
getting excited from the sun. So
yeah. So it's that homo pole, yeah.
yeah,
Oh, let's see.
the homo pole. Come on, stay. All right, let's not.
Oh man, that's funny. We're all in trouble now. There was
Yeah,
a
now you're
there
gonna
was a car with a giant cannon looking thing on it, man, or a truck, and it was putting out like mist and stuff, and it was creating a rainbow behind it. I'm thinking, man, they should just bring that out for Gay Pride Month, man. That's like the perfect thing. It's got perfect rainbow every time.
I'm not sure if the aerosols were. I mean, I know in the United States a lot of them were, but worldwide, I don't know because everybody has different. Nobody can agree on anything. Let's put it that way.
Well, I'll tell you what, those 80s chicks are hot with the big hair, you know?
Huh.
Back in
Tell
the
when
day,
somebody
man.
went to school, high school
Well, yeah, I mean,
during the 80s, right?
they tried real hard, that's for sure.
Well, hey, the 80s were good. It's good. It's all right.
Yeah, there you go, Joe. High heels and big hair. That's the way it went.
Yeah, I wouldn't doubt that there are tons of stuff used worldwide. Like I said, they're not all as stringent
Oh,
as
Budweiser
strict
calendar.
as America.
Back when they knew how to sell beer. Hot chicks and thongs sell beer. They, man, they would freak out these days. These people, man, they can't handle that. Yeah, it's worth looking back, that's for sure. Heck, I thought
Yeah.
during this whole thing, Richard Simmons was going to pop up next to me and start jazzercising. Oh, weight loss, man. I'm going. Oh, I'm dying here and hallucinating at the same time.
Sweating to the oldies. It's like, oh my God. Yeah.
Oh man, that's so bad. He, he was on that Whose Line Is It Anyway? Oh my God, that was the
Yeah.
funniest episode ever. Like, I don't know if you ever watch that show. They make up stuff and they have to do stories and use themselves as props.
Yeah.
Oh my God, if you get a chance to check it out, you'll laugh.
Whose line is it, anyways? I watch
Yeah.
that all the time.
Yeah,
It's
look
so
for the one
funny.
that was Richard Simmons in it.
Yeah, I've seen it. What about
Well,
the one with the? Oh, geez, who is it? Man, why am I going blanking on him? Well, I'll remember him later. But yeah, I watch it all the time.
well, let me tell you something. If you got a Tesla coil, you're zapping everything on the table. I'm sorry. I was.
Yeah,
Let me just tell you now. I swear, I was making a zapping stick for my Tesla coil. So this little rod at the top right here, I just connected the wire to it, man, to a wire, and it had a little rod on it, and I zapped everything to see what
yeah,
it do.
yeah. The field is pretty big on those. Like
So,
the metal around your door there will
mhm.
get hot.
Yeah, well, sure. That garage door behind me gets lots of abuse. Joe's mom used to like sweating to the oldies.
Yeah.
Huh.
Oh, he lived a painful life in the end there. Poor
Dude,
guy.
Richard Simmons is funny. I don't
Yeah,
care, dude.
he's a genuine person.
Yeah.
I don't think there was anything that was fake about that guy.
Joe said he need the special organite plug. That's funny. Yeah, by the way, John, what was your guess on the weight loss?
Oh, I didn't. I don't play with people's stuff like that. I think it's great that you're doing it, but to guess on it, I don't know. I didn't. What'd you start at?
I started at 325.
I think when you're getting done, what is it, Friday? So what,
Oh,
3 days?
yeah, we finished it a couple days ago.
Oh, you finished.
Yeah, but we didn't announce the winner yet.
Oh, yeah, I was thinking around 275.
Ah, it must look slim on the camera. Getting better.
Yeah. Yeah, it looks like you got guns now. What the fuck?
got some muscle in my arm.
Yeah.
Well, I'll tell you what, man. I don't have no fat on my arms. That's not where the fat is. It's all right in here.
Yeah.
But,
I wear the same, that breakfast burrito around my
yeah,
stomach.
there you go. Yeah. Look at that.
He's
You
been
notice
lifting
it right away.
burritos.
Got a little muscle going on there. Well, I could still put out what is it, 40s, no problem in curls every day.
Yeah, what'd Joe start at?
Just started around 221, I believe.
So I'd probably say, I don't know. He's using a secret sauce. I'm probably thinking 270. I think he beat you out a little bit. I don't know.
He was using the elixir of death to
Yeah, that's what I
to
heard.
slim down. Yeah.
He's cheating. I think.
Well, I can tell you now that the guessing's over, not the weight, because that'll be Friday. But I lost 9 pounds in 3 days.
Wow.
So, and that was at the end.
All right.
I used to.
Well, that's when you do. You first you lose the water, and then it plateaus a little bit, and then you lose a little weight. Like the fat will start coming off.
I should have told Joe that I used to wrestle, and you learn how to lose weight pretty quick, how to fast, how to do things like that. That might have helped. You know what I mean?
Yeah.
And then yeah, it's in pounds. Joe doesn't count what kilograms. What is that? What it is?
Oh, kilos.
Kilos.
Yeah.
Yeah.
Kilos.
Joe doesn't know what that is.
Keys.
Oh, gallon of fresh water weighs 8 pounds. Wow, that's a lot. No, back in high school, man, it used to be.
It's in stones.
Yeah, you go put on the trash bag, put it over your sweater over it. Same thing on the pants side, put the sweats over it. Go out and spit a bunch as you run. I ain't running these days, I'll tell you that. I'm limping around the track, but you can lose a lot of weight.
Aren't you like dehydrating yourself though? I mean,
yeah, you are. That's exactly what you're doing.
Yeah.
You could dehydrate yourself 10 pounds, no problem.
Wow.
That's why wrestlers do it. That's why they look a little bit smaller that day, look kind of scrawny, and the next day they look all big and buff. Yeah. They're rehydrated. That's the same thing with UFC fighters. That some of them are down.
Yeah, I guess.
15 pounds. Yeah. Some
Yeah.
of them down 15 pounds when they do that.
As long as you don't do it all the time, I guess.
No, it's like a 3-day event. So, well, if you're doing it right, if you're trying to do it all in one day, you're going to kill yourself. But yeah.
Oh, yeah.
Yeah, I stopped working out, to be honest with you. I put the weights down. The muscle still weighs something, and it still hurts, like my back and stuff. So I don't even care to have it.
I have a lot of issues with my back too, so most of it's because of my girth, around the stomach. Pulls at the right point.
Yeah. Well, I have screws and Yeah, I mean, there's
Oh,
4 screws, 2 plates, a little
you got
basket in
hardware.
there. Yeah, I got hardware in there.
Oh shit.
So, well, I broke one side. They call it what is it, neck of the dog.
Yeah.
So I snapped that, and then I worked for 6 months, and I snapped the other side of it at the same level, if you could believe that.
How?
Yeah, it's just lifting soda cases. That's it, off of a semi truck. So I just kept doing it, kept doing it. One day I found myself laying in the parking lot and couldn't get up. It had pulled out of alignment because it wasn't held in anymore. The necks of the dogs were broken, so the little circles part was, opening up. So that's when I called it quits and was done.
Ouch.
Yeah.
Well, mine's been working since I was a kid, so
Hmm.
scoliosis.
Oh, gotcha.
And the older I get, the more it bends. So
That's not good.
yeah, I got a chair waiting for me.
Nice.
No, not nice.
I'll be honest
Necessity,
with
but
Yeah, recliners are much better for me than beds, man. Because
yeah.
you don't have to put all your weight in one spot. You know what I mean? It's not focused.
Yeah. I sit in a gaming chair, kind of lets me lay back some.
Hmm.
So
Yeah, that's how I threw out my back last time. I put my foot up on my desk.
jeez, are we all broken here? All right. Please raise your
Yeah,
hand if you're broken.
I think everybody here is broken. I snapped my collarbone when I was a kid. Man, is
Well,
that a painful injury?
I have the Cloud 9000, so my bed's good.
Oh, nice.
It's one of those space foam beds. That's the
Yeah.
only thing I could sleep on.
Let's see. What do you say? Oh, he had a heart broken, and his wife healed it. My wife these days tears out mine. But I'm kind of gotten to the age where I ignore half the thing. I can't hear. That's number one. So now I just use it every time she starts talking and go off. I just pretend I can't hear her and walk out the door. It makes life a lot easier. Any tips to improve your circuit diagram? It depends. So he's using like a frequency generator, like a $10 one from Amazon. He uses a trigger circuit, which is the right circuit to use. Probably the $2 one from Amazon is the shape I saw. You should upgrade that one to the next level up. The reason is if when you get over 15 volts on that thing, it tends to fry. Especially if you're doing heavy amps or something like that and going to low frequency. If you're trying to move magnets on like say a geometry coil and you want to move the magnet, your amps are going to be higher to do it. So your frequency is going to be really low. So you want to get the upgraded one from there. Even at that, over time, it'll break down. So yeah, it's a high-low switch. It just basically takes in the low from the frequency generator while running the power through it on the high side. So it couples them.
Hmm.
So yeah, I mean, dude, it's a great circuit. I built that for a DC flyback. I built it to run my coils in order to get the little ball to spin, the magnet. It'll spin those things all day.
Oh, the spinners.
8.73,
Yeah.
8.73 hertz is what it likes. And also likes 103, I believe it was, hertz. It jumps up where it likes it. No, but that circuit's great. You can use it in your ZVS on your DC flyback on that circuit, by the way, and you can change the frequency of it. So it'll thin out how many amps are going into it and then thicken them. And then you can use the duty cycle as well to build up the amps on the opposite side. So yeah, that circuit's very handy. Yeah, I tried by the way, I tried it with the ZBS I got over here. Oh, I should probably turn that off.
It's been running.
Well, I had the switch off, but I left the power source on. Yeah, it doesn't like the bigger ZVS I got here. It won't push the frequency through like I like. But the little cheapies, the what do I say, 350 watts, they love that one. They don't like the 1,000 watts. So you could change frequency when you do a DC flyback as long as you get the 350-watt ones. They're a little easier. I think it's something to do with the diode in it. It's not as heavy, so it'll be able to push the frequency through. But yeah. Let's see. Yeah, I don't know what Gerald's doing these days. I haven't seen him in a while. You want to see the gravity flyer fly? So do I. You know what? I'm having the hardest time. I'm putting everything in resonance, and this thing, it doesn't want to go. And part of me thinks I just have something wrong in the building of it. And it could just be a very simple thing. I went too thin on the metal, and it's not sustaining frequency like I like. It's pulling it out too fast. It builds up energy and then it dies off. It builds up energy and dies off. I can't sustain the buildup of energy in it. So it would be much easier with a geometry coil than it would be anything else that I have. It would have been so much better. Yeah, well, dude, I'd love to have Sheila on if she would come on. Absolutely. Harmonics are not quite right, no. That's because it goes in and out of balance. And so, John, you know about leaching, right? Frequencies and high voltage.
Leaching?
So when you put the how do I say this? You put the high voltage fields together on like say just a one of those little screw down boards. You know what I mean? Just about what 4 inches long, and they have just a bunch of screw things in them, and it goes one to the next. So basically, when you put your DC flybacks on one of those and run it through it, it's producing a field in that right there. And you're not realizing it's producing a field. You think you're going, okay, this clip goes to this clip, just like DC power, but it produces a field on there. So as you put in your Tesla coil field, it's adjusting both because the Slayer oscillator is self-adjusting.
Yeah.
And then your DC flyback will adjust to what you put in there. I think that's my problem with this whole thing. I ran it individual wires. He runs that bus bar. And I think what he's doing is the frequencies are starting to balance each other in his. And in mine, they just ramp up and die and ramp up and die. I think his
Right. It doesn't
balanced.
flow. It doesn't flow in the rest of the system.
Yeah. It's like
Yeah.
it auto corrects in his, and I don't think it's auto correcting in mine. I think it's really what it comes down to because it does it on the disc. That's why it builds up the energy. But he has his building through the whole circuits of everything.
I don't know. To me, it sounds like you should almost be treating it like it's a static machine where you put energy onto the disk. You should have a static combs there and put the high voltage to that. I don't think it's a real connection that you should have there. I think it should be, you should flip the field and the disk should have that heavy current there, the magnetic thing, right? I mean, does that sound?
So I ran it in more magnetic, and it pushes the field off because of the eddy current, because it's aluminum.
Mm-hmm.
I ran it in static, and it has no problem picking up power in static, by the way. That's the one it likes. So the buildup is there. It's on the disc. The charge is there, and it seems to stay there and
Just
builds
doesn't
out.
convert. just doesn't convert, right?
Yeah, well, like I said, I can't get the frequencies to balance. That's the whole problem. The rest of it's there. Everything he said was in there is in there. It's just that one part. And I think it's that stupid little the things you look at. Okay, when you build something, you look at it and you go, "Oh, well, that looks wrong, so I'm just going to fix it when I build it," right?
Mm-hmm.
And not realizing that
You're
stupid thing
changing
that
the
he
whole
did.
thing.
Yeah, I think that's what's my problem. I keep telling people I don't want to change the material, I don't want to change this, and
Yeah.
here I am not following the plan myself, and I just go, "Oh God, why?"
Yeah, you kiboshed yourself before you did it.
Yeah, and and the answer was sitting right in front of me. I saw it on the disc. I saw the energy working with each other, and my fault. It's my fault. So
I still have to figure out. I was talking with Phil um, on the other show there, and I think I blew his mind. He was thinking about, how come the electron doesn't crash into the proton and the neutron? And I'm like, you could think of it as like buoyancy. The electron is at a certain voltage potential and it's buoyant around, it's in a soup of something and it's buoyant in that. And depending on its uh, unit charge, is what level it's on, right? So then you don't have to worry about it crashing into the nucleus. It's buoyant.
yeah,
It'll just follow that buoyant rule.
or it just rides the field.
Yeah, it's basically the same thing. Yeah,
Yeah,
it's basically the same thing.
I don't see electrons the way you guys do. I can't. It
I don't I
doesn't make
don't
sense.
I think it's more of a cloud, but people talk about them. You have to talk on their level, and I don't always know what someone's level is, so so I don't know
I
where they
always look
are.
at it. It's just a buildup of energy that was not supposed to be there, and it's creating a magnetic field because they continue to build up on there.
I think it's a shadow of the medium that we reside in. I think
Hmm.
it's a condensation of it. So it makes like an opaque shadow. It's something we can barely detect, but it's different than the background, so we can actually see something there. It's just fuzzy. And so it's like I was talking about before, it's like a pond scum. It sits on that layer and then its density is based upon, you know, the previous level and the level above that and the level above that, and then as well below as well, all the capacitance in relation to each other.
Yeah, I
It's,
just see it as kind of like a little Evo that builds out on there, and it puts the whatever's in there, the atom in resonance with the rest of it, and it holds it together. And then as it's out of resonance, it builds a second one, and
yeah.
then as it out of resonance again, it builds a third one, and they start to create different fields out of it and different things, and then different layers for each one. So it could just be that you have one layer of field and it has one, and then another layer of field has another. That I could buy. You know, but just saying that it has electrons on it just because they're there, it falls apart when you deal with the other side because there's no magnetic field.
So electrons were just made to quantify the whatever that charge was. That's all it is. It's not a thing. It's a calculation. It's a measurement. Like an erg. You know, on that level, you have to deal with quanta of energies, little packets. Because they don't know how to deal with anything else. You know, especially
Okay.
when you're measuring something in a slice of time. You know what I mean? It's hard for them to do well, they can do a slice of time. They can't do time flow. So they've thought about the 2D part of it and how it looks and acts and stuff like that. But when it gets to, you know, uh, the 3D aspect of real life, they lost everything. It's like the Schrodinger's, cat. So
Yeah.
when they open the box, their whole theory goes to shit.
Well, I think they're right to put a mathematical value on it, though. I mean, there is something there.
It's a force. It could be quantified. I mean, we just There was no better way to do it. And a lot of the earlier, teachings and stuff like that spoke about this. The electron is not real. It's a quantification. It's so we can measure things and predict and stuff like that. And somehow it turned into it's real, and the illusion has become everything. And
Oh my God. Yeah. How many multiverses do they have now? I
yeah,
mean, Jesus.
well,
That's
it,
horrifying.
the weird thing about it is if you think about a fractal, it rolls in and not in itself, and it continually does that. Well, that's actually what we're kind of seeing out in space with black holes, quote unquote, whatever they're detecting there. That lack of light or being able to pass light past that space is it's intriguing to them, and we're starting to figure some of the stuff out, but it's not easy to talk about because people get stuck in their dogmas and they don't want to learn new stuff. They think they know everything.
Well, you know me, John. I don't care.
Yeah.
I'll let you come on and say your piece. You know what I mean? Tell me what it is. Maybe I might even agree with you. You know what I mean? And start using your lingo that you do.
Well, my way is not the end way either.
Well, I know, but that's what I'm saying. Everybody has a different way. So the
No,
more
it's just
point
my
of views
take.
you get, the better off you are. Because the same old stuff hasn't worked yet. So we need something.
Yeah.
'Cause
Yeah.
it's getting kind of tiresome. They keep trying the same experiments and they go, we want anti-gravity, so let's go back and redo the same 10 or 15 experiments again and again and again. And you're getting the same results and you're happy. And yeah, I can make some views on YouTube, but you didn't forward, anything.
Right. Yeah. Yeah. And yeah. Well, all that work. I mean, we did a lot of work, back in the day, and on the forums and all that stuff. Trying to wrestle with all this stuff, and it gets to a point where people are banging you so hard on your ideas that you start to question their motives.
Yeah.
You know,
No, I've been there.
so it's
It's like when you go and you go, I'm gonna try to make this guy's craft, right? And then they go, oh, don't worry, it's a hoax. Somebody already proved it, and I watched a proving video and it sucked.
yeah, and it was nothing close to what the original was.
Yeah, and I'm just going, okay, well, all right, should I stop? I mean, do people really want the research into this, or you know what I mean? Are we just pissing into the wind here? And I can't tell you. I mean, it's not like I built the original one and said it flew, and I had it in my backyard and I could do it
Yeah,
every day. That'd be different. I'm just researching it and putting out the stuff, and I just at some point I got tired of hearing it. It was just
yeah,
like every week, oh, it's a hoax, it doesn't fly. You know what I mean? You're a charlatan, and I'm going, why? I'm just showing you what I did.
yeah. It's not like you were doing anything. It's not you had fishing line on it, and was
Yeah,
causing it to go up and down and all that stuff.
I
You
still
know,
don't see the fishing line, man. I
no, I'm just saying that's what their argument is.
No, it is, and it's frustrating, and it's like, dude, I should have just done this at home, talked
There's
to
some things
myself.
there's some things that look suspect on it, and there are some things that don't. The ones that don't are the ones that are hard to prove, you
Yeah,
know? And they're very question they make you question reality. Like, wait a minute, this is starting to look like it's like acting like a balloon on a string, and the way that it's floating and the way it's trying to move up and being held down by the string,
yeah.
the way it wafts back and forth. And then there are times where it looks kind of janky and you can see it move in discrete steps, so like someone was yanking it up.
Well, then
But
again,
that could be other things though, because we don't know what kind of circuit he's running, that per se. I mean, we know what he told us, but there are a lot of people that don't tell everything.
well, I mean, yeah, but there's some of the videos that look fake. I'll be completely honest with you. Some of them look fake, and I'll call them out myself, like a rod's attached to the ground, stuff like that.
Yeah.
But then there's some that you just can't explain,
Right.
and then you're scratching your head, going, "Well, how did that happen? Did he just do that to throw people off? Did he?" Because some people don't want to be known for the first person to do anti gravity, because then your home country would take you, put you in a lab, you'll never see you again.
There
You
are some
know?
people that just don't want you looking.
Yeah.
They don't want the possibility of anything else being real.
I mean, somebody might have got a hold of them and say, hey, make it look fake. You got to look fake enough so that we can debunk it. I mean, who
Well,
knows?
I guess that's a way to pass it off, though, right?
Yeah.
Make it look fake and then turn around and say, hey, it's not.
I mean, I
Well,
don't know.
listen, Terrio Compendez had a lot of stuff that was in boxes. It would have helped if he did not keep those secret.
Yeah.
It would have helped 1,000,000% if he had just shown what was in the boxes.
Well, he sold it to Charlie C. is what he did.
Yeah, I know what he
And
did.
but I don't know if those are the right ones. You know what I mean? It looks
Yeah.
like it. Don't get me wrong. It looks like it, but
I think he had Tesla's transformer in there. I think he had an oil filled transformer and he was just using that.
we definitely look. Here's this confusing thing. Okay, that's what got me started on this whole thing with the Tesla coil and how it works. Is because he put the wire down the center of it, and I go, "There's more there." And I kept running into anomaly after anomaly
Yeah.
after anomaly, and I
Yeah.
go,
Yeah, that backyard coil. Oh, that thing was honker. And then it had the ground wire running right through the center.
"Yeah,"
Yeah.
and I'm just like, "Okay, we got more here, so let's continue to search."
Is that what keyed you on this?
Yeah, that's
Really?
it. I just said there's 10 times more here than what people are saying. There's another field going on. I'm seeing it pick up in there. The one that got me, okay, is I was producing a static field on the disc, right? I had two DC flybacks, and they were connected in series. So it lowered my amperage down to almost nothing.
Yeah.
And I'm blasting out static electricity. Like my computer would go off 100 times
Yeah.
and making all the noise, right? And you can see it in every video. And then I put in the Tesla coil and it went away. And I said, well, what the hell is going on here, man? Why does that field go everywhere in the room? And then now that I turn on this Tesla coil, it went away and stopped.
Hmm.
So I checked it. I go, okay, let's go over to it. Let's just run a light next to it. Is it getting brighter at a certain point and then die off on each end of it, right?
Yeah.
Is there an interaction there that I'm not seeing? So that's exactly what happened. Is in the center when the two fields met at the outskirts,
Right.
there's a perfect field line around the whole thing. And then it drops off on this side and it drops off on the inside. So it's sustaining energy in that one area around it. And I said, okay, let's reverse this and see if we can push the field of the static across the room again, right?
Hmm.
But I want to do it at my pace, not its pace. So I hooked the static electricity up to the center and I ran the disc with the Tesla coil field on it. Lo and behold, I could control it by the amount of energy I put into it. It'd grow and shrink, just like this,
Right.
based on the energy. So I go, okay, I'm still getting it to light up in the center of it, not on each side of it, and now it's pushing it. So I said, you know what? There's a field effect going on here, and it really is that single moment. I go, hold on. If I wanted to create a field bubble, I just did it. I literally have a field bubble because it's holding in energy, and then it can push it out if I wanted to. But I literally have a field effect. So, I mean, how can that guy be that right on with that? Is what confused me, and be so where it doesn't fly. It's how can you get to the point where you can create a field around a craft and not make it fly? I don't get it. It didn't make any sense. So, and that's one that's like,
It's got to be hard. It's got to be something with resonance, the resonance of the signal, right?
that's what I think is the problem. Yeah. I'm not
It's not-
breaking. I don't have consistent resonance in the circuit, is what I keep saying. It's jumping. And when it jumps, you can't create the pattern of resonance you need. You have to have it consistency over time. That's
Is there a
why
way to create a phase lock for it?
that's what I keep saying about the geometry coil versus this thing. There's no moving parts in geometry coil. I can do what I want at any time I want for the length that I want. In this thing, there's so many moving parts, it's hard to do that.
Yeah.
So you get what I'm saying. You see the kind of the quandary I'm in. Unless I can get this thing to saturate early, like I said, create the correct field early, then move into the rest of the parts, then I have it. Then it self-regulates itself because of the way the Slayer exciter is built.
Right.
And if I could build the DC flyback, the circuit in the same exact way, then I have it. Then everything is self-regulating. It bounces back to each other. The fields just have to be shared early. And I think that's been my problem on it. And it's so frustrating because the damn thing will pick up a ton of energy and then start moving around. And
Well, limited state, that's the way it is. That's the way Tesla said. Tesla discovered it. We are to explore it.
No, I agree. Tesla created everything. I'm not ever going against
Even
that.
Tesla didn't know everything. He was very sketchy on a lot of it, and a lot of it was amazing to him. That's why he was so interested. He was never amazed about anything. This amazed him. So, yeah, I mean, and yeah, Russians have a lot of neat stuff, especially technical
Yeah.
engineering, I guess.
Yeah, I don't know. I'll figure it out one day.
You'll get it. It just takes time, man. It's playing with it. Once you get that eureka moment, it'll be like, why didn't I think of this before?
Well, I look at it like this. You create anti-gravity, the rest is over. I mean,
I don't think it's really anti-gravity. I think it's more how to manipulate gravity.
Oh, I don't even know if it's that. It's this whole world is a play on resonance. That's all it is. It's a play on resonance, and we're the fools. We don't know how to do anything consistency over a long period of time. We don't understand why Tesla's earthquake machine worked because it was consistency over a long period of time at the right frequency. We don't get that. So we're thinking do the test for 5 minutes and it's okay. It doesn't start picking up energy until 15 minutes. I mean, that's when it starts to hit.
Yeah, well, it depends on your school of thought. I mean, if you're thinking the way I'm thinking, that it's creating some kind of a flow, it takes a while for that flow to establish.
But it takes a while for the static to fill up inside that Tesla coil field.
Right.
All it is. That's the time it takes.
Yeah, but I think there's another flow there, and that's the one that you're talking about. After that 15 minutes, it kicks in. It starts getting stronger, and then you can...
Well, yeah, it's like a plasma field that goes around it is what's going on. They're hitting each other and creating that field in between them.
Yeah, I'm getting that tower conversation here.
Yeah, that's kind of where I'm at with it. It's doing the same. That's what I'm thinking. It's cavitation, plasma to break it, and then outside it has its own, compression out there. But
it has a whole environment to play with out there. I mean, it has the sky, the ionosphere.
Well, that's why that field was so important as a breakthrough, because it separated the calculation of the entire Earth in the millions of volts and amps, right, to a localized field that it creates it in. Now you can start to see why lower voltages work. Just like if you get something in resonance, you have to turn down the amount of energy going in, because after a while, all it does is carry the frequency. You don't need it to bring the energy. You need it to bring the frequency.
Right. Yeah. You got to convert it. Yeah.
Yeah.
At least to make it useful for us.
Well, yeah. I mean, there's always got to be a little bit of a push.
Well, I mean, AC is good in the sense that it works, I mean, it's a good way to run things. It's just loss. It's all loss.
Yeah.
And that's even with Tesla's experience in raising the voltage across transmission lines to a point where there was very little current, so there was very little loss. you'll still have to deal with loss. I mean, even the electric loss is it's not huge, but it's still a lot
Yeah.
compared.
Well, uh, I'll tell you this, John. I don't know if you ever had this experience. When I ran this thing and I had static everywhere, right?
Yeah.
I was sparking over as well onto the disc. And then I created that Tesla field. Well, the static field was outside of the Tesla field, obviously. And the sparking itself was ionizing the air.
Yeah.
Once you created those two, shit, weird stuff started happening. Okay. It, 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 it converts your room into a bubble itself. It's like weird stuff. You just got in there at 10 o'clock in the morning. You knew you'd be working on the experiment for an hour. When you turned it off, it felt like 20 minutes. It had been 6 or 7 hours. Okay. And you'd be like, well, I can't prove that. I can't show you a clock. I can't take pictures of both. But I know I wasn't in here very long. Just stuff
Well,
like that would happen.
you realize that high electric fields can mess with your mind, right?
Yeah, it might just messed with my
Because we
internal
are
clock.
electric. We are electric.
Yeah.
So you have to be careful. If you start getting like that, you need to remove yourself from the field for a little bit. Take a breath, go out, breathe some fresh air, come in and
I'm just saying that the anomaly, no matter what you did to cure it, stayed the same. It changed what was going on in my room.
yeah.
So that's why, I say there's weird stuff. It just, I mean, look, it could just be me. Who knows?
Well, I don't think I think it's valid. I mean, it happened. I mean, it doesn't, I'm not saying that it didn't happen. What I'm saying is that just like your computer reset, things that are electrically sensitive will reset as well. And that includes you,
No,
you
that
know?
could be.
So you might want to be careful until we learn more. Um, we do know that that carbon suits might help. So maybe trying to figure out some kind of environmental carbon suit, while you're playing around.
Hmm, gotcha. Yeah, I'll be honest with you, if it protects it against the energy that's going on here, I wouldn't mind wearing one.
Yeah, just so we until we know, I
Yeah.
mean, I mean, I think there is a certain. They were using like the pyramids for multiple things. One of them was for desiccating uh, flesh that was drying it out and mummifying. Um, and it was a natural way to dry things out because it does something with the water.
Hmm.
And I think that's a part, you know, this field that we have to kind of pay attention to. We have to make sure our hydration doesn't become critical, you know?
Yeah. Well, you said graphene as a suit. That would be interesting in
Well,
the way that it bonds.
carbon to graphite, graphene.
Yeah.
Yeah.
Well, you pretty much get that stuff, man, strengthen everything, and it works. So the shield of that would be probably pretty good.
Yeah. Yeah. Well, especially, just high potentials. It would short it out and it would go on the skin of it instead of you, you
Yeah.
know? So it might be a way to help. Yeah. Graphene dope suit. Yeah. Something like that. Or just carbon fiber, right? Like a carbon fiber suit.
Yeah.
You
Well, the
can make a
Hutchinson
make a zoot suit out of carbon fiber.
well, the Hutchinson effect works on the same principle. I mean, you're ionizing the air, you're creating a static field in there, you're creating a big Tesla coil field in there, and you're taking the room as a consideration as what you're doing, being that everything in there was metal. So it
Yeah.
had to be RF hot by the time he ran his Tesla coil,
Well,
everything.
it only came RF hot when he started a static bubble and then oscillated it over time. So it started wobbling like jello. And then it just
Yeah.
keeps wobbling and wobbling. It gets bigger and
Well, you
bigger
had to
and
hold it
bigger.
in, though. I mean, he had to compress that in that room.
Yeah, yeah. He
And
had a big, huge electric field there. He was
yeah.
dealing with huge radar amps. and those put out a lot of frequency, a lot of
Well, that's what I
voltage.
mean. Yeah, it's not much different, but when people start ignoring the room and start doing it in warehouses, they miss the whole effect
Yeah,
because there's too much open air there. You have to put it in a steel container, right? Build it in there, and I bet you'll get some of the effects that he got because then you'll be able to create that field. You know what I mean? Be
I
able to hold it
agree.
in.
Yeah, his was more RF too, and RF is pretty dangerous. So because he was using those radar things, that's RF. So
Yeah, those radars are what, just multiple frequencies doing the same thing. It's the same thing as your microwave oven.
huge output, dude. Huge.
Oh yeah, yeah.
Like
It's that.
20, 30,000 watts, easily.
Well, think about it. It's a resonance chamber that's inside one of those things in the magnetron. So the chamber is the exact same size, and the energy flows in a pattern around them. So it goes 1, 2, 3, 4, 5, whatever the number is, and
Yeah.
runs it. But that's the same consistent frequency it hits every single time as it goes, right?
Yeah.
And then all you do is amplify the energy and bring it down. So it's attenuating the frequency inside of that field. That's all you're doing, but the chambers are the same. So no matter what you do, it's the same frequency, however many chambers you have. And that's the same thing in a radar. That's why it works that way.
Yeah, I don't know what kind of amps he was using. He had both radar and radio, and they were all Army issue and Navy and stuff. So he had a lot of big stuff.
Yeah, once he saturated each item and each item takes its own time, then they lose the ability to hold themselves down. They're no longer in the same field that you would think of when you're outside. They're in a different field altogether. That was the interesting part. He created a locality for the bubble in the room, and that's what I think people miss because they keep calculating the Earth and saying 1,000,000 volts. Well, it's not the case.
Oh yeah, yeah. I don't know why you need 1,000,000 volts, but
Well,
I mean,
I've heard it as 1,000,000 amps. So what would happen if you sat in a crap that got hit with 1,000,000 amps? I mean,
oh well, that happens. I mean, airplanes get hit by lightning every day. You know, so
I
as
don't
long as
know.
you're not grounded, you're good. It just pass right through it or along the skin of it for most part. But
Yeah,
sometimes it will mess up their computers, as you know.
I
And
think, man, you get in there with 1,000,000 amps going through something, you may vaporize. The amount of heat that has to be in there is huge.
the good thing is that it's very high voltage, so the amps are really minuscule real amps. It's the high voltage that really is creating, like the transformation. So when it hits the skin, it's not really high voltage. It's more like 1,000,000 volts or so. Um, but if you transform it down to like 120 volts, you're talking thousands of amps. At that point, it's just another way of quantifying the energy.
Hmm.
But I don't think they're actually
Yeah, well, let
too.
me just say this. If you told me if there's 1,000,000 amps going through it, I'm not willingly getting it. Okay? Not ever. Not even close. You told me 1,000,000 volts, I'm not getting in it either.
Well, I mean, you don't necessarily. I mean, does a bird get shocked with 1,000,000 volts when it's standing on a 1,000,000 volt wire?
Well, I'm not the bird, and I'm not taking the chance.
But
Just say
you
it
know what
that
I
way.
mean, right?
No,
Bird
look,
on
I completely understand,
a
and I'm
bird on
not
a wire,
arguing that point. All I'm saying is that bird seems pretty lucky to me. Okay, that's all I'm saying.
and I don't think we really know what the 0 point is. I mean, for real. Um, I don't know if it's that balance point that's sitting in between everything, or if it's the real 0 point, like the ultimate zero. You know,
Yeah, he said birds aren't real.
birds are real. Yeah. Well, yeah, they're robots. They're drones.
Yeah, till they poo on your head,
Yeah.
and then you'll be really mad.
Don't worry about 50 years ago. Okay, we're not talking about 50 years. We're talking about now. They're not real now.
Oh,
50 years ago, they were very real.
huh. Oh, it cracks me up. Oh man, we're all on a hologram. Yep, they'd like us to believe that so they can train us to do different things like little monkeys. Yeah. What do they come up
Yeah,
with next? They should be science fiction writers. Some of these people.
actually a lot of science fiction in some of the science that's coming out.
It's like,
With
hey,
the quote unquote science.
what was the science fiction in the 50s? And somebody gives you an answer and goes, ah, that's the new physics. There we go.
Yeah.
That's what sometimes it feels
Well,
like, man.
I
They
don't
start
know. I
telling me
mean,
about all the dimensions.
Star Trek kind of predicted some things.
No,
Just
they did.
saying.
No, that's a fact.
Just saying.
Yeah, totally did.
So it shows you the ingenuity that, if you say something and put your mind to it, we can make it. We'll find a way. You know, just how you get there.
They're arguing about the birds. Wow. Okay. Wow. Now I know it's been a long day.
That's how birds charge themselves. What are you talking about?
According to my research in the field. I love it. Oh, oh,
Mr. Mission Control.
oh.
Yeah, how come nobody's hacked birds yet? Come on, get on it. Where are you hackers? Where's any you know, self
He's been serious about that. That's even better. Oh, all right. John, it's been about 2.5 hours, man. I'm exhausted.
yeah, that was fun.
Played with my Tesla coils, almost fried my computer twice.
Got to be careful about that.
With that circuit, man, I should build a worse circuit. That sounds bad. I should build a worse circuit. But
I think the key is just figuring out what is how to get the ultimate impulse, you know, and that would be more. It would be like the ultimate magnifier. You know what I mean? Because the more pure you can get that, the better it is.
Hmm.
So at least that's what I got from searching everything Tesla.
yeah, by the way, Dennis, I tried that slow motion cam. I can't get the right slow motion to do it. I don't know what the correct number is on the shutter speed or whatever it is that I'm changing. I tried my camera. It only had one setting. I got a cheap camera apparently, and then I tried it on my good camera. I got a Sony EV10, I believe it is, and I couldn't figure it out there. So I was over here trying with that light bulb to get all the colors.
I think it's something like the sampling amount or something like that. Is digital?
Mm-hmm.
Yeah. So it'd be like shutter speed with uh like a sampling size or something like that.
Yeah, I
And the
think
way
there's.
to produce more frames, and then you can go through the frames slower with your.
Yeah, I think there's two settings. There's regular slow motion and ultra slow motion.
Mhm.
Whatever I was getting wasn't it. I can tell you that. That was for sure.
So yeah, slow motion to ultra slow motion. We will leave you to decide which one is which.
Yeah, I have no idea, man. I wish I had a camera expert there with me. They could put it in the right thing and we all be able to see it.
Hmm. What kind of camera is it?
I got a Sony. I believe it's an EVZ something 10. It's like a blogging type camera, but
Oh yeah,
it's got the different lenses on it and stuff.
you won't get slow motion out of that. You need a special camera. Has a lot
Yeah.
of memory.
Yeah. Well, I paid
Because
$1,000 for this thing, man.
slow motion takes a lot of memory. So the more frames that you make, the more memory it takes.
Hmm.
So
All right. I'm
yeah,
I'm 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 done. I got to reset my garage. Everything's out of whack right now. So, John, thank you for coming on and hanging out with me and doing this,
Yeah.
man. I appreciate it.
I appreciate it too. It was cool hanging out,
Right on, everybody.
chatting with everybody.
See you guys on Friday. We're going to be eating wings and burning Nathan's mouth off. And Joe's going to be laughing and having a good time. So, all right. Oh, where did I put this thing at?
Take care, guys.
Give me a second. I got to bring up the video file. There it is.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.